Good morning, students. Today our topic is process. First, we will learn the definition of a process. The definition of a process is program in execution. It is called a process. What is meant by program in execution? We know to run a program, the CPU must load the program from secondary memory to primary memory. When a program is loaded from secondary to primary, that means the program is in execution stage. So, that is the meaning of execution. It is the definition of process. Next, we will learn the difference between program and process. Program means a meaningful sequence of instruction, whereas a processing and execution. Program is a passive entity, but process is an active entity. That is the difference between program and process. Next, we will learn about what is PCB, process control block. When a user initiates execution of a new process, the operating system creates a data structure in the computer memory which contains the key information of a process. What are the key information of a process? The key information of the process is PID. The first point is PID, that means process identification number. Number 2, PPID. PPID means parent ID of the current process. Number 3, program counter. Program counter contains the address of the next instruction to be executed. Number 4, process state. What does process state tell? Process states tell that whether the process is in new or ready, or it is running, or it is waiting, or it is exiting. We'll see with an example in my next lecture or in the next section. So, this is the different process state. Next, we will get here the CPU register. That means to execute this process, how many CPU register it will use. It may use accumulator, index register, stack pointer, general purpose register, etc. Next, it will contain CPU scheduling information. CPU scheduling information means whether the process will run by FCFS or SJF or round robin or priority. How or the which scheduling algorithm the CPU will follow, that will we get from the CPU scheduling information. Next, we will get memory management information. The memory management information will store the memory limit that will use by the process to get executed. Number 8, input output status information. To execute this process or for execution of this process, how many input output devices will be used, that is kept in input output status information. Next, we will learn the diagram of a process state. The diagram of a process state will be like this one. Here is your new. Next we will get ready. After that we will get running. Here you will be waiting. Here is your terminated. These are the different process state. When a process is first created, it is called newborn process. After that, it will go in the ready queue. When the admitted operation is performed, it will go to the ready queue. After ready, when the using scheduler dispatch, it will go to the running state. If an interrupt comes, the running state will change into ready state. From the running to waiting, when it happens, when the input-output event failure occurs, then running state is changes to waiting state. And when this is completed, that means input-output event completion, then it will change its state from waiting to ready. And after ready, when the exit system call is performed, then it is called terminated. So, we can conclude that there are 5 stages: new, ready, running, waiting and terminated. And these are the system call that helps the process to change its state. It is the diagram of a process state. Next, we will learn about process scheduling. Next will be process scheduling. Why process scheduling is required? Because it is required as it is the basis of multi-programming. That's why the process scheduling is required. Here, CPU scheduling algorithm decide how the CPU will be allocated to the process. There are different type of scheduler. One is long term, another one is short term, another one is medium term. The long term scheduler, what it does, select processes from the pool and loads them into memory. Number 2, contains the degree of multi-programming. What does it means? Here is your CPU, here is your main memory, here is your secondary memory. It loads the program from secondary memory to main memory, that is done by long term. It controls the degree of multiprogramming. Degree of multiprogramming means number of program reside in main memory. When the main memory becomes full, it will swap the processes from main memory to secondary memory. This way it controls the degree of multiprogramming. Next, we will learn about what is short-term scheduler. Short-term scheduler select processes from the ready queue. So, select processes from ready queue and allocate to the CPU. So, that is the basic function of short-term scheduler. Next, we learn about medium term. What does medium term? Medium term scheduler does? it does the context switch. What does the means of context switch? Context means the state of a process. Switching means switch from one process to another. Switching the CPU to another process require a performing a state save and state restore. State save of the current process and state restore of the different process. This technique is known as context switch. Next, we learn about dispatcher. What dispatcher module does? It is a module that connects CPU to the process selected by the short-term scheduler. The function of dispatcher is that it has two functions. Number one is switching. Two primary functions of the dispatcher are switching and number two is jumping. Switching means switch CPU from one process to another, and jumping means jump to the proper location in the user program and be ready to start execution. So that is the meaning of jumping. So switching means switch the CPU from one process to another. Jumping means jump to the proper location in the user program and be ready to start execution. So that are the two basic primary functions that is done by the dispatcher. Next we will learn what is dispatch latency. Dispatch latency means the time it takes for the dispatcher to stop one process and bring another process to the running state. So the time between stop one process and bring another process to the running state is called dispatcher latency. So the summary of today's lecture is, first we learn about what is process. Number two, difference between program and process. Number three, what we learn? We learn about process control block. Number four, diagram of a process state. Number five, we have learned about scheduler, long, medium, short. Next, we know about context switch. Next, we know about dispatcher. Next, we have learned about dispatch latency. Thank you.